Chapter 10. Compound Interest. You have studied how to calculate the simple interest in the previous class. Simple interest is calculated only on the principal amount throughout the loan period. If P represents the principal, R the rate percent per annum, and T the time in years, then simple interest SI is given by the relation SI is equal to P into R into T upon 100. Suppose Mohan borrows a sum of Rs 2000 at the rate of interest 10% per annum for 2 years. How much extra money simple interest he has to pay, and what will be the total money amount he will repay? Now, P is equal to Rs 2000, R is equal to 10% per annum, T is equal to 2 years. Interest on Rs 100 for the first year is equal to Rs 10. Interest on Rs 1 for the first year is equal to Rs 10 upon 100. Therefore, interest on Rs 2000 for the first year is equal to Rs 10 upon 100 into 2000, which is equal to Rs 200. Interest for 1 year on Rs 2000 is equal to Rs 200. Interest for 2 years on Rs 2000 is equal to Rs 2 into 200, which is equal to Rs 400. He has to pay Rs 400 extra as simple interest. Total amount he will have to pay is equal to principal plus simple interest, which is equal to Rs 2000 plus Rs 400, which is equal to Rs 2400. We can also arrive at the same result by using the formula SI is equal to P into R into T upon 100, which is equal to Rs 2000 into 10 into 2 upon 100, which is equal to Rs 400. Compound interest. Now, suppose Mohan borrowed the same amount of Rs 2000 for a year, but fails to pay and decides to repay next year. SI at the end of first year is equal to Rs 200. He had to pay Rs 2000 plus Rs 200, which is equal to Rs 2200 at the end of the year, which he fails to pay. Now, for the second year, interest will be calculated on Rs 2200, which will be the principal for second year. Interest on Rs 100 for 1 year is equal to Rs 10. Interest on Rs 1 for the 1 year is equal to Rs 10 upon 100. Therefore, interest on Rs 2200 for 1 year is equal to Rs 10 upon 100 into 2200, which is equal to Rs 220. At the end of second year, he will have to pay Rs 2200 plus 220, which is equal to Rs 2420 as amount. If the interest is calculated on the amount of previous year as above, then the interest is called compound interest, CI. To find compound interest, when interest is compounded annually. Example, calculate the compound interest on Rs 8000 for 2 years at 5% per annum. Solution. Principal for first year is equal to Rs 8000. Rate of interest is equal to 5% per annum. Interest on first year is equal to Rs 8000 into 5 into 1 upon 100, which is equal to Rs 400. Amount at the end of first year is equal to Rs 8000 plus 400, which is equal to Rs 8400. Interest for second year is equal to Rs 8400 into 5 into 1 upon 100, which is equal to Rs 420. Amount at the end of second year is equal to Rs 8400 plus 420, which is equal to Rs 8820. Compound interest is equal to amount minus principal, which is equal to Rs 8820 minus 8000, which is equal to Rs 820.
To find compound interest when interest is compounded half yearly. If the rate of interest is R% per annum and the interest is compounded half yearly, then the rate of interest will be R divided by 2% per half year. Example, find the compound interest of rupees 6,000 for 1.5 years at 10% per annum, interest being paid half yearly. Solution: principal is equal to rupees 6,000. Rate of interest is equal to 10% per annum is equal to 5% per half year. Time is equal to 1.5 years is equal to 3 half years. Interest for the first half year is equal to rupees 6,000 multiplied by 5 multiplied by 1 divided by 100 is equal to rupees 300. Amount at the end of first half year is equal to rupees 6,000 plus 300 is equal to rupees 6,300. Principal for the second half year is equal to rupees 6,300. Interest for the second half year is equal to rupees 6,300 multiplied by 5 multiplied by 1 divided by 100 is equal to rupees 315. Amount at the end of second half year is equal to rupees 6,300 plus 315 is equal to rupees 6,615. Principal for the third half year is equal to rupees 6,615. Interest for the third half year is equal to rupees 6,615 multiplied by 5 multiplied by 1 divided by 100 is equal to rupees 330.75. Amount at the end of third year is equal to rupees 6,615 plus 330.75 is equal to rupees 6,945.75. Therefore, compound interest is equal to rupees 6,945.75 minus 6,000 is equal to rupees 945.75. To find compound interest when interest is compounded quarterly. If the rate of interest is R% per annum and the interest is compounded quarterly, then the rate is R divided by 4% per quarter. Example, find the compound interest on rupees 8,000 for 1 year at 20% per annum, interest being payable quarterly. Solution: principal is equal to rupees 8,000. Rate of interest is equal to 20% per annum is equal to 20 by 4% is equal to 5% per quarter. Time is equal to 1 year is equal to 4 quarters. Interest for first quarter is equal to rupees 8,000 multiplied by 5 multiplied by 1 divided by 100 is equal to rupees 400. Amount at the end of first quarter is equal to rupees 8,000 plus 400 is equal to rupees 8,400. Principal for second quarter is equal to rupees 8,400. Interest for second quarter is equal to rupees 8,400 multiplied by 5 multiplied by 1 divided by 100 is equal to rupees 420. Amount at the end of second quarter is equal to rupees 8,400 plus 420 is equal to rupees 8,820. Principal for third quarter is equal to rupees 8,820. Interest for third quarter is equal to rupees bracket 8,820 multiplied by 5 multiplied by 1 divided by 100 is equal to rupees 441. Amount at the end of third quarter is equal to rupees 8,820 plus 441 is equal to rupees 9,261. Principal for fourth quarter is equal to rupees 9,261. Interest for fourth quarter is equal to rupees 9,261 multiplied by 5 multiplied by 1 divided by 100 is equal to rupees 463.05. Amount at the end of fourth quarter is equal to rupees 9,261 plus 463.05 is equal to rupees 9,724.05. Therefore, compound interest is equal to rupees 9,724.05 minus 8,000 is equal to rupees 1,724.05. Formula for compound interest. Let P be the principal and R the rate percent per annum. Amount after 1 year is equal to P plus interest for 1 year is equal to P plus P multiplied by R multiplied by 1 divided by 100. T is equal to 1 year is equal to P multiplied by 1 plus R divided by 100. Principal for second year is equal to P bracket 1 plus R divided by 100.
Interest for second year is equal to P into 1 plus R upon 100 into R into 1 upon 100, which is equal to P into 1 plus R upon 100 into R upon 100. Amount at the end of second year is equal to P into 1 plus R upon 100 plus P into 1 plus R upon 100 into R upon 100, which is equal to P into 1 plus R upon 100 into 1 plus R upon 100, which is equal to P into 1 plus R upon 100 square. Principal for third year is equal to P into 1 plus R upon 100 square. Interest for third year is equal to P into 1 plus R upon 100 square into R into 1 upon 100, which is equal to P into 1 plus R upon 100 square into R upon 100. Amount at the end of third year is equal to P into 1 plus R upon 100 square plus P into 1 plus R upon 100 square into R upon 100, which is equal to P into 1 plus R upon 100 square into 1 plus R upon 100, P into 1 plus R upon 100 cube. Continuing in the same manner we have, therefore, amount at the end of T years is equal to P into 1 plus R upon 100 raised to the power T. Compound interest. CI is equal to P into 1 plus R upon 100 raised to the power T minus P. Case 1. To find the compound interest and amount when interest is compounded annually. If principal is equal to P, rate percent per annum is equal to R, time is equal to T years. Then A is equal to P into 1 plus R upon 100 raised to the power T compounded annually. CI is equal to A minus P, which is equal to P into 1 plus R upon 100 raised to the power T minus P. Example: find the amount and compound interest. Principal is equal to rupees 5,000. Rate is equal to 5% per annum. T is equal to 3 years. Solution: we have A is equal to P into 1 plus R upon 100 raised to the power T. A is equal to rupees 5,000 into 1 plus 5 upon 100 cube. A is equal to rupees 5,000 into 1 plus 1 upon 20 cube. A is equal to rupees 5,000 into 21 upon 20 into 21 upon 20 into 21 upon 20. A is equal to rupees 5,788.125. Amount is equal to rupees 5,788.13. Now, CI is equal to amount minus principal. Compound interest is equal to rupees 5,788.13 minus 5,000, which is equal to rupees 788.13. Case 2. To find the compound interest when interest is compounded annually, but rates are different for each year. If rate of interest be R1% per annum for first year, R2% per annum for second year, R3% per annum for third year, and so on, then amount is equal to P into 1 plus R1 upon 100 into 1 plus R2 upon 100 into 1 plus R3 upon 100, and so on. Example: find the compound interest on rupees 25,000 after 2 years compounded annually. The rate of interest being 5% per annum for the first year and 6% per annum during the second year. Solution: principal is equal to rupees 25,000. R1 is equal to 5% per annum. R2 is equal to 6% per annum. Time is equal to 2 years. Amount is equal to P into 1 plus R1 upon 100 into 1 plus R2 upon 100, which is equal to rupees 25,000 into 1 plus 5 upon 100 into 1 plus 6 upon 100, which is equal to rupees 25,000 into 1 plus 1 upon 20 into 1 plus 3 upon 50, which is equal to rupees 25,000 into 21 upon 20 into 53 upon 50, which is equal to rupees 27,825. Compound interest is equal to amount minus principal, which is equal to rupees 27,825 minus 25,000, which is equal to rupees 2,825. Hence, the compound interest is rupees 2,825. Case 3. To find the compound interest and amount when interest is compounded half-yearly. Let principal equal to rupees P, rate R% per annum, and time T years. If interest is compounded half-yearly, then rate is equal to R upon 2% per half year. Time is equal to 2T half years. Amount is equal to P into 1 plus R upon 2 into 100 raised to the power 2T. Example: find the compound interest on rupees 12,000 for 1.5 years at 8% per annum, compounded semi-annually. Solution: principal is equal to rupees 12,000. Time is equal to 1.5 years, which is equal to 3 half years. Rate is equal to 8% per annum, which is equal to 8 upon 2% per half year, which is equal to 4% per half year. Amount is equal to rupees 12,000 into 1 plus 4 upon 100 cube, which is equal to rupees 12,000 into 1 plus 1 upon 25 cube, which is equal to rupees 12,000 into 26 upon 25 cube, which is equal to 12,000 into 26 upon 25 into 26 upon 25 into 26 upon 25, which is equal to rupees 13,498.368. Amount is equal to rupees 13,498.37. Compound interest is equal to amount minus principal. Compound interest is equal to rupees 13,498.37 minus 12,000, which is equal to rupees 1,498.37. Case 4. To find amount and compound interest when interest is compounded quarterly. Let principal is equal to rupees P. Rate is equal to R% per annum, T 1 year, if interest is compounded quarterly. Therefore, rate is equal to R upon 4% per quarter. Time is equal to 40 quarters. Amount is equal to P into 1 plus R upon 4 into 100 raised to the power 4t. Example: Manu took a loan of rupees 32,000 for 1 year at 20% per annum, compounded quarterly. How much he has to pay after 1 year? Solution: Principal P is equal to rupees 32,000. Rate is equal to 20% per annum, which is equal to 20 upon 4% per quarter, which is equal to 5% per quarter. Time: 1 year, which is equal to 4 quarters. A is equal to P into 1 plus R upon 100 raised to the power T. A is equal to rupees 32,000 into 1 plus 5 upon 100 raised to the power 4. A is equal to rupees 32,000 into 1 plus 1 upon 20 raised to the power 4. A is equal to rupees 32,000 into 21 upon 20 raised to the power 4, which is equal to rupees 32,000 into 21 upon 20 into 21 upon 20 into 21 upon 20 into 21 upon 20, which is equal to rupees 38,896.20. Amount is equal to rupees 38,896.20. Case 5. When interest is compounded annually and time is a fraction. Where interest is compounded annually but time is a fraction, say 3 and 2 upon 5 years. Amount is equal to P into 1 plus R upon 100 cube into 1 plus 2 upon 5 into R upon 100. Example: Find the compound interest on rupees 62,500 at 8% per annum for 2 and 3 upon 4 years. Solution: P is equal to rupees 62,500. R is equal to 8%. T is equal to 2 and 3 upon 4 years. Amount after 2 and 3 upon 4 years is equal to rupees 62,500 into 1 plus 8 upon 100 whole square into 1 plus 3 upon 4 into 8 upon 100, which is equal to rupees 62,500 into 27 upon 25 whole square into 53 upon 50, which is equal to rupees 77,274. Compound interest is equal to amount minus principal, which is equal to rupees 77,274 minus rupees 62,500, which is equal to rupees 14,774. Miscellaneous cases. Now we know that how to find amount and compound interest when principal, rate and time period is given. We shall discuss now how to find each of three quantities, that is principal, rate and time, when compound interest, amount and other relevant information are provided. Case 1. To find principal when CI, amount, rate and time period is given. Example: Rahim deposited certain amount in a bank to earn interest at 10% per annum. He received rupees 2,662 from the bank after 3 years. Find the sum deposited. Solution. Amount Rs 2,662. Rate 10% per annum. Time 3 years. Amount is equal to P into 1 plus R upon 100 raised to the power T. This implies Rs 2,662 is equal to P into 1 plus 10 upon 100 cube. This implies Rs 2,662 is equal to P into 1 plus 1 upon 10 cube. This implies Rs 2,662 is equal to P into 11 upon 10 cube. This implies Rs 2,662 is equal to P into 11 upon 10 into 11 upon 10 into 11 upon 10. This implies Rs 2,662 is equal to 1,331 upon 1,000 into P. This implies P is equal to Rs 2,662 into 1,000 upon 1,331, which is equal to Rs 2,000. Hence, sum deposited is Rs 2,000. Case 2. To find rate of interest. Example. At what rate % per annum compounded annually will a sum of Rs 1,000 amount to Rs 1,331 in 3 years? Solution. Amount is equal to Rs 1,331, principal Rs 1,000, time 3 years. A is equal to P into 1 plus R upon 100 raised to the power T. This implies 1,331 is equal to 1,000 into 1 plus R upon 100 cube. This implies 1,331 upon 1,000 is equal to 1 plus R upon 100 cube. This implies 11 upon 10 cube is equal to 1 plus R upon 100 cube. This implies 11 upon 10 is equal to 1 plus R upon 100. If A raised to the power m is equal to B raised to the power m, where A, B greater than 0, then A is equal to B. This implies R upon 100 is equal to 11 upon 10 minus 1. This implies R upon 100 is equal to 1 upon 10. This implies R is equal to 10%. To find time period. Example. In what time will Rs 1,800 amount to Rs 2,178 at 10% per annum, compounded annually? Solution. Here. A. Rs 2,178. B. Rs 1,800. R. 10% per annum. A is equal to P into 1 plus R upon 100 raised to the power T. This implies 2,178 is equal to 1,800 into 1 plus 10 upon 100 raised to the power T. This implies 2,178 upon 1,800 is equal to 1 plus 1 upon 10 raised to the power T. This implies 2,178 upon 1,800 is equal to 11 upon 10 whole raised to the power T. This implies 121 upon 100 is equal to 11 upon 10 raised to the power T. If A raised to the power m is equal to A raised to the power n, where A, B greater than 0, then m is equal to n. This implies 11 upon 10 square is equal to 11 upon 10 raised to the power t. T is equal to 2 years. Hence, time period is 2 years. Growth. There are few quantities which increase in magnitude over a period of time. For example, population, height and weight of living organisms, etc. The relative increase in a quantity is known as growth, and growth per unit of time is called the rate of growth. The formula and procedure of computing amount and compound interest is applied in finding the rate of growth. Case 1. If P0 is the population of a town in the beginning and is increasing at a rate R% per annum, then after T years, the population is given by P is equal to P0 into 1 plus R upon 100 raised to the power T. Case 2. If P0 is the initial population and it increases at the rate of R1% during first year and R2% during second year, then the population after 2 years is given by P is equal to P0 into 1 plus R1 upon 100 into 1 plus R2 upon 100. It can be extended for 3 years, 4 years, and so on. Case 3. If certain quantity or population decreases at the rate of R% per annum with the time period T, then P is equal to P0 into 1 minus R upon 100 raised to the power T. Example, the population of a town is increasing at the rate of 10% per annum. What will be the population of the town at this rate after 2 years if the present population is 42,000? Solution. Present population P0 is equal to 42,000. Rate is equal to 10% per annum. Time period 2 years. P is equal to P0 into 1 plus R upon 100 whole raised to the power T is equal to 42,000 into 1 plus 10 upon 100 whole square, which is equal to 42,000 into 1 plus 1 upon 10 whole square, which is equal to 42,000 into 11 upon 10 whole square, which is equal to 42,000 into 11 upon 10 into 11 upon 10, which is equal to 50,820. Hence, the population of the town after 2 years will be 50,820. Example, Bhanu invested rupees 40,000 in a business. In the first year, he incurred a loss of 10%. During the second year, he earned a profit of 5%, which in the third year rose to 20%. Calculate his profit for the entire period of 3 years. Solution. The initial investment, P0, is equal to 40,000 rupees. Now, P is equal to P0 into 1 minus R1 upon 100 into 1 plus R2 upon 100 into 1 plus R3 upon 100. This implies P is equal to rupees 40,000 into 1 minus 10 upon 100 into 1 plus 5 upon 100 into 1 plus 20 upon 100. This implies P is equal to rupees 40,000 into 1 minus 1 upon 10 into 1 plus 1 upon 20 into 1 plus 1 upon 5. This implies P is equal to rupees 40,000 into 9 upon 10 into 21 upon 20 into 6 upon 5. This implies P is equal to rupees 45,360. Therefore, net profit is equal to P minus P0, which is equal to rupees 45,360 minus 40,000, which is equal to rupees 5,360. Depreciation. The value of certain quantities or things decreases with the passing years. It means reduction of value due to use, wear and tear, and the age of the item. The relative decrease in the value over a period of time is called its depreciation. Depreciation per unit of time is called the rate of depreciation. The value at any time is called the depreciated value. If initial price of an item was P0 and its value depreciates by R% per annum, then after T years, its price P is given by the relation P is equal to P0 into 1 minus R upon 100 whole raised to the power T. Example, the value of a car costing rupees 1,45,000 depreciates at the rate of 20% per annum. What will be its total depreciation after 3 years? Solution. Initial price of car P0 is equal to rupees 1,45,000. Rate is equal to 20% per annum. Let P be the price after 3 years. Since the value depreciates, therefore, P is equal to P0 into 1 minus R upon 100 whole raised to the power D. This implies P is equal to rupees 1,45,000 into 1 minus 20 upon 100 cube. This implies P is equal to rupees 1,45,000 into 1 minus 1 upon 5 cube. This implies P is equal to rupees 1,45,000 into 4 upon 5 cube. This implies P is equal to rupees 1,45,000 into 4 upon 5 into 4 upon 5 into 4 upon 5, which is equal to rupees 74,240. Total depreciation is equal to P0 minus P, which is equal to rupees 1,45,000 minus 74,240, which is equal to rupees 70,760. Example: a refrigerator costs rupees 16,000. Its price depreciates at the rate of 5% per annum during first 2 years and 10% next year. What will be the price of the refrigerator after 3 years? Solution: the initial price of refrigerator P0 is equal to rupees 16,000. Let P be the price after 3 years. P is equal to P0 into 1 minus R1 upon 100 into 1 minus R2 upon 100 into 1 minus R3 upon 100. This implies P is equal to rupees 16,000 into 1 minus 5 upon 100 into 1 minus 5 upon 100 into 1 minus 10 upon 100. This implies P is equal to 16,000 into 1 minus 1 upon 20 into 1 minus 1 upon 20 into 1 minus 1 upon 10. This implies P is equal to rupees 16,000 into 19 upon 20 into 19 upon 20 into 9 upon 10, which is equal to rupees 12,996. Hence, the price of refrigerator after 3 years will be rupees 12,996.